In this screencast, we are going to perform a hypothesis test to find out if the statement "home is where the heart is" should be rejected or not. In order for us to create a hypothesis testing on this statement, we were required to gather real data from the public. We decided to use a very simple survey which included two questions. Number 1, do you live where you grew up? Where the respondent was asked to answer either yes or no. And number 2, if no, where do you feel your home is? Where you live now or where you're from? After receiving 39 responses on our survey, which we found was a sufficient amount to run a somewhat accurate hypothesis test, the results showed that for question 1, 16 people answered yes, meaning that they live where they grew up, and the remaining 57.9% of the respondents answered no, which meant they do not live where they grew up. As we can see from our pie chart here on the left, the large proportion of respondents do not live where they grew up. For question 2, 36.8% of the people feel that their home is where they live now, and 65.8% of the respondents feel that their home is where they are from. As we can see from our bar chart here on the left, the larger proportion of respondents feel that their home is where they are from. We used a summary of the results in the survey and applied them to an Excel sheet which included 3 columns. In the first column is the timestamp with the date and time each response was recorded. In the second column was question 1, do you live where you grew up? With all the answers below to each response, either yes or no. And finally in the third column was question 2, if no, where do you feel your home is? Again, following all the answers to each response, either where you live now or where you're from. The chi-square test is used to test if the difference between expected and observed results is significant. So here we have our observed data. We surveyed 39 people asking them 1, do you live where you grew up? Where the respondent answered either yes or no. And 2, where do you feel your home is? Where the respondent answered either where you live now or where you're from. We then sorted these results and presented them in this table. The table shows that 11 people who live where they grew up feel that this is where their home is, and 5 people feel that their home is where they are from. Of the respondents who answered no, which means they don't live where they grew up, 4 feel that their home is where they live now, and 19 feel that home is where they are from. We are going to use this data to test our hypothesis. The hypothesis to be tested is the null hypothesis. We will make our null hypothesis that more than 50% of the people regard their place of birth as their home. We will also use the alternative hypothesis, H1, that more than 50% of people do not regard their place of birth as their home. The first thing we need to do is get our expected cell frequencies. We will compute the expected cell frequencies using this formula. The row total multiplied by the column total and then divided by the number of respondents in total. For example, to calculate the expected cell frequency of those who live where they grew up and call where they live now their home, we take the total of this column here, which is 15. We then take the total of this row, which is 16, and we multiply them together. We then divide that answer by the total number of respondents, which is 39, which will give us our cell frequency of 6.16. We carry out this same formula for each cell to get each cell frequency. The next thing we need to do is calculate our chi-square stat, using the formula where the sum of our observed score is subtracted by our expected score and then squared, and then is divided by our expected score again. The decision rule is, if the chi-square stat is greater than the test stat, we can reject our null hypothesis. Otherwise, do not reject the null hypothesis. Our test stat is from the chi-square distribution with the number of rows minus 1 multiplied by the number of columns minus 1. The degrees of freedom for this project is 2 rows minus 1 multiplied by 2 columns minus 1, which gives us a total of 1 multiplied by 1, which equals to 1 degree of freedom. So, as I explained in the previous slide, we're going to use this formula to get our chi-squared stat. We take our observed score of 11 here and subtract our expected score of 6.16 and we square our answer, dividing by our expected score again of 6.16. We carry out this same method for each cell. One cell here, another cell, and our final cell. Adding each answer together gives us our chi-squared stat of 10.51178. From the tables, our test stat with a 0.05 significance level and a 1 degree of freedom, we get a test stat of 3.841. So, when we worked out our chi-stat, we got a value of 10.51178. We can then compare our chi-stat with our test stat. We can clearly see that our chi-stat is greater than our test stat. From this, we can reject our null hypothesis and come to the conclusion that there is sufficient evidence to believe that less than 50% of people regard their place of birth as their home. So, here we're just going to verify our results using Excel. We have our observed table here on the left and our expected table here on the right. To get our cell frequencies in our expected table, we take the cell with the total for each column, which is 15 and 24, and multiply by the total of each row, which is 16 and 23. Dividing these answers by the total number of respondents, which in this case is 39. In our chi-squared table here, for us to get these values, we take the cells of our observed data, so in this example I'll use 11, subtract it from our expected value, which is 6.15, and then divide it by that same expected value of 6.15, which will give us an answer of 3.82 here. We carry out this same formula to get each chi-squared stat. Adding each chi-squared stat together gives us a chi-squared stat of 10.52. Our test stat then is from the tables with a 0.05 level of significance and 1 degree of freedom, which gives us 3.84. We then ran an if function to say if the chi-stat is larger than the test stat, it should read reject, and if not, it should read not reject. In this case, it should reject our null hypothesis. That is, that less than 50% of people regard their place of birth as their home.